Okay, so just a few information about today. This part of the course won't be in the test of the tuw-python lecture. So what we are going to learn today, it is not you don't need to learn it for the test, and also you will be able to get extra points, but today is rather a demonstration, so I'm going to present you a project structure in Python, and I will present a little data science project. So, and the main takeaway from today will be that how you need to structure your Python code if you are in a project, and how should you separate the logic in your application from the UI, because until today we were learning how does Python work through examples in Jupyter notebook, and like Jupyter notebook is a very widely used tool in data science. You have also seen it, how great tool it is for learning through examples, learning the language, experimenting with the examples, because in one place you can run the code and you can see the result. You also have the documentation in one place, so it's like all in one package. But when you want to collaborate with other people, you want to build a project, in a lot of cases Jupyter is not enough, because that way you cannot really give a running example to other people. So it's not structured, you just have the functions in one place. So yeah, that's what I want to teach you today, how to do it in other way, and how to, when you have a data science project, the first thing is to process the data. Today we will also process a data set, build a knowledge base, so a graph knowledge base from the data, and we will also build a front end to present it, so visualize it in a web application. So that's what we are going to learn today. I will present you lots of packages in Python. You don't need to learn all of them, and at the end you will have a very little task that you can complete to get the extra points. So you don't need to write a lot of code, just to complete one function. So it won't be that hard, I think, but we will see. Because this is the first time I'm presenting this material on this course, so we will see how it goes. First, you need to clone the repository. Everything will be in this repository. And yeah, that is how we start. We can start this. And let me know if you had some problems with cloning the repository to your computer. So this is a GitHub repository, and everything will be here. This contains the lecture and the exercise material for the 5th lecture and exercise in this course. And this lecture aims to introduce the concept of separating code into different modules and packages, Python packages. And also we will also learn how to install and use a repository as a Python package. Also, we will cover a basic data science task. We will use the book A Song of Ice and Fire as our data set. I preprocessed it, so you don't need to do that. It will be in the data folder. We will look at the repository structure and how everything is structured, where you can find everything, and so on. The task will be to find character mentions in the book, namely finding more characters mentioned in one sentence. So if the book mentioned multiple characters in one sentence, we want to find these mentions. And if multiple characters will be mentioned in one sentence in the book, we want to build a graph from it. So characters that were mentioned together in a sentence, the characters will be the nodes, and we will write an arrow between the two nodes if that two node were mentioned together in one sentence. So that will be the task. And for using graphs in Python, we will use the Network-X library. It is an open source library for handling graphs in Python and also visualizing the network. You will see it is a great package for that, and it is easy to use also. And then to serve the knowledge base that we built with Network-X, we will build a web server, a simple web server, also in Python, to serve this network through a REST API. So it will be available in a web server. And also we will also use a visualization library. It is named Streamlit. If you will work in data science, I think you will meet with Streamlit. So it will come handy for you that you have already seen it. It is, I think, one of the most widely used visualization package for data science and machine learning. It also starts a web interface. So your Python code that you wrote, the results we will present it in a web interface nicely, purely written in Python. So that is also important. You don't need to write like JavaScript and React and so on. It is only in Python. And also I have included tests. It is in the tests folder, but I will talk about it later. So the main idea was with this exercise is to show how to implement a data science project with a web server, a web interface, and not just only using Jupyter notebooks. In this project, we will only use the Jupyter for demonstration purposes. And that is what it is for, basically. You will need an IDE to work with this project. You can use PyCharm, VS Code, or even simple like Vim, if you prefer that, but it's completely up to you. You just need to open the files, basically, so whatever you prefer. So we worked with Anaconda and Anaconda environments. If you install Anaconda and you open Anaconda prompt, it will open the basic environment that it installed. An environment is it defines the Python version and the packages that you install in this environment. Like Jupyter is a Python package that you can install in an environment. Until now, you have used only one environment, the basic environment, I think, that Anaconda installed for you natively. But for each project, it is a good practice to separate each project into a different Python environments with different Python version, with different packages, like pip packages. You install the Wikipedia module with pip that was installed in your environment. But now with Anaconda, we will create different environment just for this project, and we will install the dependencies of this project into this environment, into this specific environment. And when you install a package with pip, like the Wikipedia module, you installed it from the pip repository. So you download it from there when you were running the pip command. It downloads the package and installs to your computer. But you can also define a package in a GitHub repository, and you can install that package with pip also, and that later can be used anywhere in your computer. So today we will also install a package that is in the GitHub repository. So first, one of the first things that we need to do is to create a new Anaconda environment for this package, and for that you will need a command line. You can open the Anaconda prompt command line. You can also, if you are on Linux, you can use the standard command line in Linux, also in Mac OS, if you use that. But the main thing that conda, the command conda should work. So if it doesn't work, you won't be able to install the packages. I will be using Linux for this exercise. So yeah, you see that the conda command works for me. So I will create a new Python 3.10 environment for this project. You can copy the commands from the repository.
Sorry, we need to be in the folder of the project to create an environment.
No, you don't need to. You don't need to. You don't need to. But it's better. You can navigate there. But if you install a new environment, it's not specific to the path that you are on when you are installing it. So that doesn't matter where you are.
Okay, but how do we?
Yes, sorry.
Oh, yeah. Is this lecture intended that we code along with you, or will it be too fast and we'll just see it as a presentation and do it afterwards?
Sorry, I didn't get the beginning of what you said.
Is it intended that we code along with you in this lecture now, or?
So you follow the presentation?
Yeah. Follow.
I
and
mean,
do everything at home, or?
No, well, you don't. If you don't want to, you don't need to. But if you want the extra points, you can do it at home also. Like everything is written here in the
Okay.
And also you can watch the video after if you prefer that.
Okay,
so,
thank you.
So whatever you prefer, you can follow me. I try to keep the pace that in a way that you can follow me. You can also complete it at home with watching the video and the GitHub README. So whatever you prefer.
Thank you.
Yeah, but you need to complete these steps if you want to get the extra points, because then at the end you need to complete a little task like this. So okay, we will see. So first I create a new Python environment. It will take like a half minute or so. And after that, I called my environment PyNLP because of the course. If you install the environment, you see the information at the end that you can activate this environment. You need to activate the environment if you want to install packages into this environment. So I created a new environment here. Now I'm activating it. And how do you know that you activated the environment? Because on the left, you can see the name here. So it was base before, but I created a new one. Now it's PyNLP here. So now you have a clean environment that only the base Python packages are installed here, and you can install everything only for just this project. First, in the PyNLP folder, I have a knowledge graph class. And to use this class, you need to import it. In Jupyter Notebook, you can also import a class and use this. And if you want to be able to import it from anywhere, I mean, if it is not bound to a path, you need to install it to your environment. So later, you will be able to use this class anywhere. Like, for example, in the test folder, we have a test file, and here I'm going to use this knowledge graph class. But before I can use it, I need to install the package, the Python module for this. So I can use the classes from that module. And here I have a folder for the Python module. It's called PyNLP5. So first I install that package to this environment, the knowledge base class. It's important to run the pip command like this. So pip install, and you need the E flag here. It's called, it will install this package in a development mode, because later you will need to, we will change a little this class. And if we don't use the E flag here, like we did before, we didn't use the E flag because we didn't want to install the packages in a development mode. Here I want to install it like that, because if it is installed like in a development mode, it will follow the changes. So if you make changes in the class, you will also be able to use that changes instantly. You don't need to reinstall the package. So, and the dot here means that we don't want to install it from the pip repository, but we want to install it from locally, so from the path, so from this folder. So this is the first thing that we will do. Yes?
A quick question. I get
Sure.
do we need to position ourselves in command line where the Git repository clone is? Because
yes, yes, you need to, after, now you need to, when you are installing the package.
Because with running pip, I get does not appear to be a Python project, which is really not.
Yes, I mean, you need to navigate here into the folder. Did you navigate here in your
No,
command line?
but I need to before doing conda commands, or
No, the best thing is that you navigate to your folder instantly, but the conda commands doesn't need, you don't need to run it in the folder. It doesn't matter. But the pip command, you need to run it in the folder because it installs from the folder. So this dot is the path. So I've written here like this. So you need to be in the repository before running this command. And if it was successful, you can see, you will see something like successfully installed, and it installed a lot of packages that is needed for this exercise. And how does it know what it needs to install for this exercise? We have a setup.py here, and it exactly tells the requirements that this repository needs. Like we define the name here, so the package name will be PyNL-P5. Yeah, you can give the description, and also in the install requires you can give the dependencies of this project. So we will need Streamlit package, Python package. We will need the Flask package, the iter-tools package, and so on. So it is defined here. And when we run the pip command, it installed everything that is defined in the setup.py file. Okay, now you also need to install some other packages that will be required for the visualization. It is called the Streamlit graph package. It is a modified version. But what you need to do is just copy this command and run on the same command line that you did before, and it will install the package to this environment. And
what is the difference between installing it through pip and through conda?
It's just channels. So like the conda has a channel that it reaches to when installing packages. Pip also has a channel, but if you use pip inside conda, like we did here, it installs it correctly. So you can use both conda and pip also. So, but some packages can only be available from pip, for example. So it's not available in the conda channel.
Thanks.
Okay, now also it is like, let's just install these two additional packages. The black is the formatter, code formatter. I will show you how to format your code with this. The PyTest is required for running tests in the repository. And also I will install Jupyter here because it is a new environment, so Jupyter might not be available from here. So I will also run these two commands here. And if I copied every command here, I should be ready with the dependencies. Yes, sorry.
What about the networks package? Shouldn't it be installed too? Because
you mean the graph package, right? But
yes, because it's not being installed after all these steps I've also done.
Yes, that is because one of the packages here that we installed, I think the Streamlit graph package, includes the package, so you don't need to install it separately because it will include it. So if I run pip install networkx now, it says requirement already satisfied because one of the packages installed this package already, so you don't need to do that.
Are you sure? Okay.
Yeah, for me, yes. When I run
okay.
pip install, it says already satisfied. So, but we can check the.
Maybe I forgot something.
It doesn't work for you.
At least maybe I skipped some step, but I got an error when I did the next step.
Oh, okay.
But we will come to it. We will see if it works.
Yeah.
Okay.
Yeah, I went to the streamlit graph package, and in the setup.py, it says that it will install networkx. So it should do it. But if it is not for you, then you might have skipped some. I think you need to run this step to install networkx. But if it is not for you, you can just run it separately, like pip install networkx, and it will install it for you. Okay, now to just make sure that that you installed networkx and the package correctly, I think just try to run. No, I'm not running it yet. We just go through the directory structure, and then later we will start the services. So how is the architecture of the repository and how we structure the directory? So we will have three components in this repository. We will have the knowledge graph. That is what we installed. It is a Python package. We will use the networkx package here. It will process the files, and it will implement the graph algorithms. Then we will have a backend. It will be a web service using Flask, the Flask repository. The Flask repository is a Python package for defining web services over Python. And it will be responsible for providing the data for the front end. So it will use the knowledge graph, and it will return the knowledge graph for the front end. And the front end will use the streamlit package. It will be responsible for the UI, so the web interface, how our web application looks like. And note how we separated the logic here of the application from the visualization. It is pretty good because this way we can easily change the visualization without changing the backend, and also reversed, so we can change the visualization without changing the backend. And also we could define multiple front-end components here that uses the same backend and has different visualizations. So we separate logic here in a different components, so we can change the components easily. And we can also change the graph backend, the knowledge graph here. For example, if we want to use a new package, not networkx, but like another graph backend, we can easily change that also because it's separated from the other modules. And also because we have a web service here that deploys this knowledge graph into a REST API with a REST API. We can deploy the two components, so the backend and the front end, into different computers because they will be available through web interfaces. That is a very good strategy, because if you will be doing machine learning projects or data science projects, you might have big components as your backends, like serving machine learning models. But you want to visualize it on a client somewhere. So you might want to deploy your machine learning model into a service or server that uses GPU, so lots of resources, right? But your client can be on a small machine running somewhere. that only visualizes the model. So you don't need GPU for that. And if you are running your backend on a web server, you can deploy it anywhere and you can access it from the front end. So it can be on different machines. It is pretty. It's important to do that sometimes. So what is the structure? First, we have the data folder here. The data folder contains our data, the books. So we will work with this file, the SSB 1 line. It's called line because it is separated line by line. So we have sentences on different lines, and this is the whole book. So we want to process it. We want to find character mentions on same sentences, in same sentences. Like we can search for an example. Like here, in this line, we have 2 characters mentioned, like Gareth and Sir Weimar. So we have 2 different characters here. We want to find these 2 characters, and because they were mentioned in the same sentence, we can add an edge to the graph between these 2 nodes. So the characters will be the nodes, and we add an edge between them because they were mentioned in the same sentence. So from the data folder, we will process these files. We have the characters also here, so we don't need to know that. Like we have it defined. We don't need to guess what are the characters. So we have a file where the characters are defined. So we just need to read it from here. And also we have a file, character aliases, which defines different names for each character, but it is not that important right now. The main thing is that we have the data folder and all the data are here. In the examples folder, you will find examples how to use the packages. I will go through them quickly, and then we can go to the exercise. In the images folder, I just have some sample images that were used in the repository. So you can include it from this folder. In the PyNLP folder, you have the Python package, the knowledge base defined. I will go through this code after we run the server. In the scripts folder, I have the preprocessed data .py script. You don't need to understand it. I just added it here in case you are interested how I preprocessed the book. So I separated it line by line. It is a little NLP task, but it's not that course that you need to know how it is done. We have another for that. So in the services, we have the backend and the front-end service. And in the backend service, we have the Flask REST API defined using the knowledge graph. And it starts a web service on localhost. So locally, you will start a web service, and then you can make requests to this web service, and then you will see the data. And also, I have the front end defined here that will use the Streamlit package. It will define how the front end looks like. And also it will make the requests to the backend service, like you see here. It will use the requests package to make get and post requests to the web service. But we will see how it works. Also have a utils file here. It just defines some functions that doesn't belong to anywhere else. And also in the tests folder, I have the tests, the assert test that we had in Jupyter. Now we have it in a Python file, in Python files. So we will see how we can run it. And also we have the README here that is defined here, and also we have the setup. I already talked about it. So this is the structure of the repository. So just to make sure things are running, let's start a Jupyter notebook in the folder here. So you type Jupyter notebook, and it should start a Jupyter server locally. If you started it, you can just go to the localhost and the port, and then we can go to examples. So you see here the directory structure. You can go to examples and the lecture, and yeah, we have some examples here how to use the packages. So first, how do we serialize files, and how do we read the files in from yes, someone has a question.
I've seen in your prompt that you also installed some more packages, or at least I think I've seen network is okay, that's written here. Or is there something we have to import or install that is not mentioned in the README that
you have an error somewhere, or
please?
You have an error, so something doesn't run for you?
Not yet, but because you opened your prompt before,
Yes.
and I've seen that you install things that I don't see in the GitHub in the README file. So I'm just asking if I have to scroll down, or if there are things you only mentioned but are not written in the README.
No, everything should be written in the README. So
okay.
If something doesn't work, that's a mistake on my part. So the command for starting Jupyter notebook is Jupyter notebook. Yeah, so that is the command. Okay, for so serializing JSON files to disk and then read it from the disk, you will have the JSON package, and with that we can use the JSON package to open the characters, for example, and then it is a pretty handy package when you are working with web service and so on. So basically, you can just use it to write dictionaries to disks and reading dictionaries from disk, like JSON files are dictionaries, for example. Okay, so the networkx package, as I said, it is for handling graphs. But how do we define graphs in the networkx? First, you need to import the networkx package, as we did before. And then first, you need to define an empty graph. How do you define an empty graph? Like this. You just call the graph function of the networkx, and then you will have an empty graph defined like this. So you don't have any nodes, it doesn't have any edges also. First, we will add some nodes to it. So it has a function called add nodes from, and it you can give it a list of strings, and it will add those nodes from the list of strings. So if I run this command, we will have these nodes in the graph. Also, you can add it separately, so not from a list, but just a string. Like I added add.start to the nodes. I can use the add node function. Also,
excuse me.
Yes.
Somebody asked, could you zoom in a bit so it's easier to read on a smaller screen?
I have a big screen. Sorry.
And do you maybe have an idea? I did pip install Jupyter, and it says requirements are already satisfied. But when I write Jupyter Notebook, it says it isn't a CMD let. So
if you want to start Jupyter, it doesn't start.
No, it says it doesn't know the command Jupyter, but if I pip install Jupyter, it says it already exists. So
yeah, you need the command Jupyter notebook, so not just Jupyter. Maybe that's the problem.
it still gets the same error. It doesn't open. Can I just open a Jupyter notebook and then open the correct file from there? This should be possible, right? So I just have to find where the Jupyter notebook is that we are using right
So
now.
you yes,
Because
but
I used it the last days as well, so it worked. So
yes, yes, it works, but then you need to make sure that when you start the Jupyter notebook from Anaconda, you will have the same environment that we defined, because it might start from another, and then in that we won't have the packages. So if you type in pip install Jupyter, it says
exactly what you have here.
yes, and when you type in Jupyter notebook, it won't start, right?
No, it
So,
says it's not a CMD-led name not found.
what type of terminal do you use? Anaconda or?
I did before, it was still open, but I opened it from the Visual Studio terminal. Maybe that was the issue. I'm going to try again.
Okay. For the others, does it work?
Yes.
Can you import the network fix? Okay, great. That's great.
Yeah, I installed through Visual Code and terminal, and it worked. So maybe it's
okay. That's good. I was a little afraid because these things can be a little tricky, these environments, but it's very useful for you to understand these things, because when you will be data scientist, you will work with these custom packages that requires every kind of requirements like dependencies, and you will need to be able to handle these environments separately, and then make sure that that you are starting things from the correct environment. So it might be a little confusing for now for you, but I advise you to learn these like after the lecture, I mean, when you start your data science career or courses. I mean, these are very important things. Okay, so adding edges, like the add edge or add edges from function requires two node IDs, and for us the IDs are strings. So you can just give the two nodes that you want to have connected, and also it has attributes like edge attributes. You can add, for example, we will add weight. The weight here means how many times they were mentioned together. So, for example, Jon Snow and Arya Stark were mentioned together 2 times. Jon Snow with Sansa Stark was mentioned together 3 times, for example. But it's not the correct numbers. I just made it up. But so it has 3 parameters, 2 node IDs, and the dictionary with the edge attributes that you want to have in your graph. So let's just add the edges. And then after you have added all the edges and the nodes, you are able to query the graph and see what are added here and what are not. For example, I can see the nodes property or function, and it will return a list with all the nodes in the graph. So you see we have nodes here. Nodes can also have attributes, but we didn't add anything right now. For example, the Jon Snow node could have an attribute alias, and then it will have like King in the North or something like that. Also, the edges, you can list the edges. It is also a list. So Jon Snow is connected to Arya Stark with this attribute. So it is just lists basically. You can update any edge you want with an attribute. For example, like here we have Jon Snow and Arya Stark with weight 2, but we want to update it to 3. We can access the edge like this between Jon Snow and Arya Stark, and we want to update the weight attribute to have 3 mentions. And after that, we have the 3 mentioned here correctly. Some useful things when working with NetworkX, it has a huge number of algorithms and defined here. And for example, let's look one, like the centrality, the degree of a node. You can just find an algorithm defined in NetworkX in their documentation. So you can just go to networkx.org, and everything is open source. So you search for degree centrality. It computes the degree centrality for nodes, for example. You can click on source, and you can also look at the implementation. So everything is open. That's why it is a pretty great package. And also sometimes it links the papers to the that defines these algorithms. So you can also check those. So that's why I like this package. Okay, let's go back to the tuw-python notebook. For example, if you want to have only a subgraph, so you don't want the whole graph, but you only want to query subgraph of the graph, you can use the subgraph function with the node list, and then it will only return that graph and then the edges between only these nodes. So if I query the edges, no, it will only be from these nodes. So basically between these nodes. How do you use the algorithms defined in NetworkX? For example, the shortest path between 2 nodes are defined in NetworkX generally. So you can use networkx.shortest path. You give it a graph. For us, it will be the G graph, and then you give it 2 node IDs. So I want to have the shortest path between Jon Snow and Khal Drogo. I can just provide the 2 names, and I have the path here in a list. So we start from Jon Snow, we go then to Joffrey Baratheon, then to Daenerys, and then to Khal Drogo. So this is the shortest path between the 2 nodes. Then you can just select the edges that are between these nodes, and then you have the shortest path there. You can also visualize graphs. NetworkX has a draw function. So this is how the graph looks like. And that is why tuw-python is such a great tool. You can also see the plot here where you are writing the code. So yeah, and you see that, like, for example, Sansa Stark is connected to Jon Snow. Jon Snow is connected to lots of others. So okay, these were the main things about NetworkX, and we won't really use much other. So these are enough to understand the exercise. If you are interested in the package, you can look up the documentation or ask us. So we use NetworkX a lot. We will also use regular expressions to match characters in lines. For that, we have the re module in Python. It is built in, so I don't think you need to install it. For example, I want to match John, then I can write any kind of regular expression with this package. Like if I just write John, it will return lines that has John in it. If I want to search for Sir Weimar, you can use the find iter function, and it returns all the matches. The search only returns the first match, but if you want all the matches, you can use the find iter package. And as I said, you can provide any kind of regular expressions to this module, and it will return the matches. For example, I want to search for names, so first name and then the last name. And how do I do that? Like I assume a name has 2 separate words. with uppercase, so like first man or Karl Drogo. So I can write this regular expression here that it starts with any letters, but the first is uppercase, and it continues with lowercase letters, and it can be any times. So the lowercase letters, we can have any number of lowercase letters, but only one uppercase at the beginning. And we have two words like this. The asterisk here means that we can have like anytime we want this. And I searched for the most common names that were mentioned the most. So for example, like Theon Greyjoy was mentioned 6 times. Sir Weimar was mentioned multiple times. So okay, let's go back, I think, and look at the Flask example also. You would want to open multiple terminals at this point, if that's possible for you. So I'm going to open another terminal because we can't really use this because we started Jupyter from this. So now it can be used. Cannot be used. Why I can't? I mean, it's just very slow. I don't want these. Sorry for the. Yeah, I need a Ubuntu. So I have 2 terminals now. And in the second terminal, I'm also activating my environment because that's what I installed. Then I navigate to the repository. So I'm here now. So in the second terminal, you also have the PyNLP activated. You are on the right path in your repository. And now let's look at let's open, I'm going to open a visual code here so you see the structure better. And I want to show you the example, the Flask example from the examples folder. So this is how a web service looks like in Flask, defined in Flask. Basically, you just you need to import Flask from the package that you installed. You need to have a host. Where do you want it to be deployed? I want it to be deployed locally, so I want to access it from the browser if I type in the URL localhost. And also I want it to be run on this port. And then if you run the server, if I start this Python file, it will start the web service on localhost with this port. And it has routes, so it has functions which connects to URL routes. So you can access, for example, this method. If you type in the browser localhost with this port and /hello. We will try it out. So I will start this web service. I go to the examples folder. I type in Python Flask example, and it will start the web service. You see here, it says serving Flask app Flask example. We started it in debug mode, and it says it is running on localhost. We can also test it. So you can go to the browser and you can type in localhost and the port number. And if you started it correctly, it will start the web service locally, and you will see the hello world here because we just returned hello world in the index, so in the root path. But for example, I can, if I want to access this route, it's the hello route. then I can type in hello, and it will return hello none. Because in this function, I use the request package to access the name attribute from the URL. Because I didn't give it any name attribute, it returned none, because name here is none. But if I say that my name is Adam, this is the URL. So hello, question mark, and then you can provide your arguments here. So name equals Adam, and you can access it from the function. Okay, so basically this. Also, you can define variables here, and then you can access those also. So, for example, I have a root get data, and it returns this dictionary. Or I have an add data path, and you can add values to the dictionary.
Excuse me, could you show us how you would add data as a dictionary in the?
Sure. I have a example here for that. So you not only can so not just from the browser you can access the localhost, but you can make requests to that from Python, from tuw-python notebook. You have the requests package. So sorry, I have a problem with my keyboard, but so the first is we did the same in the browser, but now we are doing it in Python. We access the hello path here. This is a simple get method, so we didn't provide any kind of data. Only we queried the path. So let's query the get data, and we have this dictionary here. But now we want to add data to this dictionary. We can make a post request to that. So we also provide data in the body, not in the URL. So we call the localhost add data path, but we provide a JSON in the body. So a dictionary, basically. We add the key, the JSON, and the value will be 1. And here in the Flex service, you can see that with the request package, you can call get JSON, and it will access the body. So you can access what the client added here. So if I call this, we add the data to the dictionary, and then if we call get data again, it will also return to that value. So John and 1. Okay, I think these were the main things about Flex that you need for the exercise. I will stop you see here all the queries that we made. So it prints out like we accessed hello, we accessed add data, and so on. But now to stop it, you need to push Ctrl+C, and it will stop the web service. Okay, let's look at the Streamlit example, so the front end. This was the back end, but it's just an example. And now we will look at the front end of the application. It will contain a lot of, like, I wrote lots of examples here, but it is very simple. So Streamlit is a very simple app to use. You can just go to streamlit.io. It has a great documentation. So it has lots of examples how to use the methods and so on. It has a gallery, so you can browse applications built with Streamlit. I clicked on one, so see if it is live. Maybe it won't be live, but so this is how a Streamlit application looks like, for example, and it was made purely in Python. You don't need to understand this. The main thing is that you can create beautiful applications from out of the box. But you can't really change how it looks like, but it is very good for demonstration purposes. If you don't want to bother with the front end, but you still want to show your app to someone. So that's what we are going to use it for. So how can you start a Streamlit application? I have in the examples folder, I have the Streamlit example.py. You have a .py file for a Streamlit application, and here you just only need to import the Streamlit package, import Streamlit as st, and then from the st you can use all the functions here to just write build the front end. So, and if you have this, you have the Streamlit example, you can navigate here to the path, and you can run Streamlit run. If you install with pip, Streamlit should be accessible from the command line also, because it is a module installed. So you can run Streamlit, run Streamlit example, enter. And if everything is correct, it will open a web application locally on a port. And this is the examples that I provided here. So, for example, you can just add the title to the application like this. Hello Python class. This is a header, like a subheader. You have all these functions. You can also write Markdown to Streamlit using the Markdown function. You can write any information using the write function. The write function is kind of a magic function. It writes out basically anything. For example, if I want to write out a dictionary, you can modify the source code, and Streamlit tells you that the source file changed. And it says, do you want to rerun? Yes, I do want to rerun, and it changes the front end. So it's pretty easy to implement this, because you can have a splitted screen. In the one on the left side, you can define the code. In the right side, you will see the result instantly. So yeah, this is why it's good for it. It's kind of like tuw-python notebook, so you see the result instantly, basically. Yeah, it can also show examples. For some reason, it's pretty bad quality, but I delete the bit, so I have it in correct resolution. It has checkbox, so, and you can just write st.checkbox, and it will show you a checkbox with the provided examples. Or radio buttons, like here, select your favorite pet. Is it a dog or is it a cat? And in a variable, it will store your selection. So like conditionally, you can choose what was selected. For example, like select box here, it is defined like this. You just need to call select box with a list, and it will define a select box exactly where you put it. Yeah, and you can see your selection. So it is an interactive front end, which is also pretty important. So it's pretty easy to get the user input and then show the information based on that input. You will see it in the example how we will use it to display graphs from the backend. How we will query the knowledge base. Yeah, you have buttons here. You can just define streamlit.button, and then you give it a string, and it will show that string for you. And how do you know if a button was clicked or not? Here, if you can just define the button, the about button here, and if it is clicked, you can just call it like this. If button was clicked, then write down this. So if I click on the about button, it will write down this information. So it knows when it was clicked and when it was not. Yeah, and I have a little app here at the bottom, a simple calculator. But one thing that is not that simple in Streamlit is storing variables across calls, across sessions. Because Streamlit, if something changes in the app, it reruns the whole app from the beginning. So if you want to store something, like here, I want to store all the results, you can just store it in a variable because it will run the whole app again. So you need to store it in a session state. It's called streamlit.session state. So not just don't just introduce a new variable, but if you want to store it between clicks, you want to store it in a session state. That's where it stores between up refreshes. So for example, here I add two numbers together. You know, like 2 added to 3, the result is 5. And we calculate it again. And here at the top, you will see the results that we had before. So it stores the information between clicks. And this is why the session state is for storing information that you want persisted. And this is, I think, the hardest part about Streamlit, to remember what you want to store between every refresh and what you don't want to store. Streamlit also have lots of tutorials, so if you will be interested, you can watch it. You can go to the documentation. It also explains everything pretty clearly. So Streamlit is good because it enables fast prototyping. You can show your results to someone very easily and very fast. And you know, it looks better when someone asks what are your results? What are your model's results? What is the result of your data science project? And if you just show a JSON file or something, that doesn't look as good as showing a website that shows the results, shows the visualizations. And Streamlit is exactly what it is good for: demonstrating results, demonstrating algorithms. How does it work? How does your application work? Okay, I think that's it. Let's start now the services. So I will close the Streamlit application. You can close it with Ctrl+C the same way, and then you can close the browser also. I will also close the Jupyter in the other in my other terminal with Control-C. Yeah, make sure you close it with Control-C and not Control-D or something, because then it will kill the not close it, it will kill it, and the port remains occupied, so or in use, and then you won't be able to start the application on the same port again until you kill the server running on that specific port. So make sure to close it correctly. Okay, this is the web page. Now let's open the application that we have. So first, let's start the Flask server of the application. So let's start the backend. We have the services folder. So I will just navigate to services and I will start the backend. And it will start the backend over the knowledge base. And then we need to run the front end. So in my second terminal, I'm navigating to the services folder, and then I'm running the Streamlit application. So it can be started in two ways. I suggest you start with the second. We could start like this and don't providing anything. Like it is a command line argument. We provide a file to the Streamlit application because I already preprocessed the knowledge base. So if you start it like this, you will need to process the files. So matching the characters, building the knowledge base. But I already did it. So you will have the serialized knowledge base in a JSON file. You can just provide it to the Streamlit application, and then you won't need to process it because it would take like a few minutes, like 2 or 3 minutes. And if you don't want to waste time, but you can try it at home. So could you process it with Streamlit? So I will just run this command. So now it can become a little complex because you have two services right now in two terminals. And then you might have another terminal running the Jupyter notebook. So you need to pay attention what is running where and in what environment. This is important. But it should be running. If you started the backend and the front end, we have this is the application. It looks nice, isn't it? No, I mean, you need to click on the build button first, but then we will look at the code, what exactly happens. So let's click on build here. If we click on build, it builds the knowledge base either from the path that we provide, or either it parses the files, matches characters, builds the network graphs, and so on. If you go to the where you started the backend, it shows what were the queries. So we called the build method from the front end. Now we have the knowledge base loaded in. So Streamlit command, Streamlit run, and then the file, the Python file. In the README, you can find it in the how to run the infrastructure. And here we have the start the Streamlit server, and start with the what is below with the provided JSON file. What we have here is basically just querying the knowledge base with different algorithms. So I have just a select box with a query type. So for example, I want to query the neighbors of a node. So what character was mentioned with this character and how many times it was mentioned. So for example, I want to know that Robert Baratheon was mentioned with whom, and then I can select the character and click on get neighbor, and if everything is right, it will show you a graph here in the right column. I will also show you how can you make a layout in Streamlit. So we have two columns here. In the left column, we have the selection box. In the right column, we have the graph showed. So I use the custom package Streamlit graph. It is a dynamic graph, so you can make all these kinds of fancy stuffs, selecting one node. I have other algorithms implemented. So for example, now I only queried the immediate neighbors, so characters that was directly mentioned with Robert. So for example, Eddard Stark was mentioned with Robert Baratheon 51 times. So this is his most mentioned neighbor. But let's say I want to query the neighbors of the neighbors. So I run the algorithm with that too. We will have a much larger graph like this. Here we have Robert Baratheon. We have the immediate neighbors like this, and then the neighbors of the neighbors. Yeah, I can zoom in a little more. And it is the package is completely customizable. So you can customize how does it look like, how does it works. You can go to the documentation of the graph package. I also have implemented the character with the most connections. It's basically just we just count the degree of each node. So the outgoing, we summarizing the outgoing edge weights together and then finding the maximum value. And this is Eddard Stark. We also show here some information. So with the most connection is Eddard Stark with more than 192 connections. And then we have another two algorithms, the isolated characters and the shortest path, which are not implemented yet. These are the two tasks that you need to complete to get the extra points. We will do the first one together. Okay, so we will go through the code, look what and where it is implemented, and then we also will complete the first one together. You can get 7 points from this, and then you can get 8 points from the shortest path. And then the shortest path, you can do it alone after we did the first together. And now, any questions regarding running this? And if someone couldn't run the application, something is not working, they can ask now. And then in the afternoon, we will go to the code.
I sometimes have problems stopping the services. It takes like 20 times pressing Control-C. Is there a way to kill it?
It's a Windows-specific things. I know about this because I already had a problem. That's why I'm not. I'm not using Windows for anything. I have heard that you need to keep open the tab and also kill the application then. So don't close the app and then try to close the application because it takes more time.
Close the tab.
Okay, then then it's just a problem, I think, with Windows and then with the Streamlit. I think it closes if you click it one time, but it takes time, right? So yeah, that's a pity. So you are mostly going to the data science masters, right? So this will be your topic. I mean, you want to work in data science.
Yes.
Yeah.
There are some of you who already had data science education, right? So it's not completely new then for you.
Yeah, I have a question. I tried to run the Streamlit for front end.
Sorry, but you are pretty. I don't hear you correctly.
Do you hear me now?
I hear
Oh.
you, but you have. I mean, I don't get what you are saying.
Is it better now?
Yes, yes, it is better.
Okay. I tried to run the Streamlit for front end, and I get an error. No such option. Okay.
I think you wrote it with an error, so you are on the G.
No, I've wrote KG. Both are there, but it still doesn't work.
So you run it like this, and it still doesn't work.
Yeah.
What kind of terminal do you use?
This is the CMD, so just on the normal command prompt in Windows.
I'm afraid it might not work there. Maybe.
For me, it did. I did exactly the same. I opened the command line interface in Windows with and to the services folder, and from there, opened the file, and it worked in my case. So
I had to kill it before because I did a wrong command, so I started again, and I just have to start with conda activate by NLP, and then go to the services and then start this. There's nothing more needed, or?
Yes,
exactly.
If it doesn't work, try with git bash. Maybe it should be installed if you install git. And it's a better terminal than just CMD. Like it has Linux commands built in, like the ls, the cd.
Okay, I will try. Thank you.
Yeah, it might support this, I think. Yeah, what I'm doing, and I also suggest it to you, if you will work with data science. Try to, if you are using Windows and not Linux, you should have Linux installed because it makes lots of things much easier. And you can install Linux under Windows. It's called WSL, Windows Subsystem. And that way you can open a Ubuntu terminal inside Windows. So if here, if I install that, you see I have an Ubuntu here, and it is a complete Linux kernel. So you can use anything with, like you use with Linux, but it is under Windows, and it forwards anything to Windows. So you also see the result, like the web application, but it runs under Linux. So you have all the pros of using such. It's much better command line than Windows. So I suggest you to try this. It makes lots of things easier. But if you insist on keeping Windows, that's also fine. But sometimes it makes things harder because with a lot of packages, they don't really test it on Windows. That's what I have found so far.
I have another question.
Yes.
It's also with Streamlit. I think I've installed everything as you mentioned before, and when I'm in the services folder and I issue the command Streamlit run frontend.py, etc., it says me Streamlit command not found. What could be? It's a.
Did you activate the correct environment? So you open the terminal.
Yes.
And then here it doesn't open in that environment. So you also need to write conda activate and the environment name before you.
Okay, thank you.
You can see on the left side.
Yeah, you can
my,
see the left side.
my new terminal is still in the base environment.
Yes, you need to activate your environment because
yeah, now it works. Thanks a lot.
Yeah, and it is also pretty good to keep multiple environments for project. I mean, one for a project, because then you don't mess up the requirements. In my experience, if you install a lot of these custom open source data science projects, it will mess up. Like some of that needs network x 1.3 and the other one needs network x 2.6. And then if you install everything in one environment, it will mess up the dependencies and nothing will work. Yeah.
Thank you.
I have a question too. You opened the VLC before from the Conda, from the Anaconda command line.
So I opened what exactly? Sorry, I didn't get what.
You opened the project, right? The repository.
Yes, I opened. I mean, I cloned the project and then I opened the Anaconda from command line. So I didn't open it from. I mean.
Yeah, that's clear. That's clear. But you went into the project folder and then you typed open or VLC or.
I didn't. Yeah, you mean the tuw-python, right? So running the tuw-python or.
Yeah, but no, then I missed it. Also, then I misunderstood it. I think that the Jupyter notebook I could start. I just thought you also somehow opened the VLC from the Anaconda prompt, but you did not.
You mean the VS Code, right?
Yes. Sorry.
Yes, I did. I did open it from here. I added it to the path, but I mean, you can open it from like you can just open it from here and then open the project. But I'm always doing it from. I'm always doing everything from the command line.
Yeah.
This is just my way of working, and then I have the code path added here. So if I type in code and then the path, the dot, it opens this directory, so I don't need to open it from.
Oh, okay, thanks. That was what I wanted to know. It was code dot. Thank you.
Yes, and I also have something like if I want to open Explorer here, I just type in Explorer. It should open, but it somehow freezes. Yeah, and I have the files here. So I'm trying to add lots of things to the path, so I can open everything from from the command line.
Yes, I mean, I have it on the path to, in Windows, you have to add anything manually to the path anyway when you install it, so.
Yes, in Windows, that's also, yeah, that's not that good.
Thank you.
Okay, thank you. Then we will see each other from 1, and then we will go through the code and completing one of the tasks also.
Cool, thanks. Bye.
Bye.
Thanks for the great lecture.
Yeah, it was super. Thanks.
Yeah, thank you for being here.
Yes.
Keeping with me.
Thank you.
Thank you.
Thank you.
Bye-bye.